you go to our conference. Have you been to our conference? Fun, right? We're taking to DC. We're going to be Washington, DC, our nation's capital, to another 2-day conference. One of my speakers is right here. You're up. That's one of my speakers right there. But if any other speakers from DC in the room? No, I guess most of them are in DC. There will be a few New Yorkers there. It'll be a fun time. If you want to attend, you can go to rstaff.ai and you can use discount code NYACR for 20% discount. If anyone's looking to sponsor either that conference or this meetup, let us know. We're also going to sponsors to help take care of some things that end up costing us a lot. And lastly, we're going to go to the bar afterwards. We're going to go to AOA Bar and Grill. It's just a couple blocks that way, maybe a few blocks that way. Show of hands, who has been to AOA and knows where it is? Those of you are going to be your Pied Pipers. At the end of the meetup, they will meet you there in waves. That means you have to go now that you raise your hands. Paul, don't act like you weren't going anyway. All right. With that, a little bit of tonight's talk. It was the first time we've done something quite like this. A few months ago, J.D. Long, otherwise known as C Mastication, gave a talk on dplyr with a song title that half the audience was too young to understand. And that's apparently people say, wait, they didn't get it as a song title. But this time we have Bill Gold here doing counterpoint, doing almost the same exact slideshow with another old music song reference. Where instead of dplyr, he's going to substitute in Datatable, which is one of the chief competitors, the chief competitor for dplyr. This should be a really fun night. I offer you Bill.
Thank you. Test, test. Can you guys hear me? Excellent. Okay, so then present mode. For the last, 10, 15 years or so, part of what I've been responsible for is building out model development platforms. And I've been doing this on a very, very large scale. Not like Google big or Facebook big, but just a shade below that. The most recent generation of model platforms I built has been based on R. And it is by far the best model development platform I've worked with. It's awesome, it's super fast, and it's got all the benefits of working with R, open source. And a big part of why that works so well, why it's so fast, is Datatable. So as Jared pointed out, a few months back, a member of our community, J.D. Long, presented on dplyr. Very cool talk, very compelling, a little controversial. Who knew that the assignment operator can work left to right? That night, what I was thinking is it would be really cool to be inspired by what JD presented, but look at it through a Datatable lens. Sent Jared a message, sent JD a message. They were both pretty jazzed, so here we are. So in addition to being inspired by JD's format, we're also using some of his puns. So Life in the Fast Lane, awesome song by Joe Walsh and the Eagles. An alternate title. Didn't think it would come across the way I might want it to in an email, but okay. Where are we going today? First, we'll talk about why should we consider using Datatable. We'll get into some of the key benefits, some of the design philosophies that Matt Dole, the creator of this package, put into it, because I think that flavor of why Datatable is the way it is helps, at least it helped me come through the learning curve and maybe help you get your heads wrapped around it. Then we'll shift gears, we'll go into the syntax, we'll go into some of the breadth and depth of what Datatable can offer. After that, we'll start looking at some real-world examples, some cool things, I think. Functions I've layered on top of Datatable, real-world code snippets that highlight and hopefully leave you with the impression of what Datatable looks like in a real-world environment and why it might be a compelling package to use. Then we'll dive into something unexpected that's very, very much related to Datatable. And last, we'll talk about some cool next steps they're all related to data. Some are connected with Datatable, some not so much, but I think they're fun. A little bit about me. Think of me, please, as part management consultant, part data scientist, part technologist. I started my career as a developer, trained as an electrical engineer. I brought to market commercial software with millions of lines of code. Very often found myself building the ecosystems that models need to thrive. Built and trained hundreds of models across the customer lifecycle, mostly in finance, insurance, and medical technology. And yeah, I guest lecture at Columbia and NYU on the topics of computer vision, data, and data analytics. And I'm with a company called Teva. Here's how you can reach me. It's Bill C. Gold and all these platforms. And tonight's presentation will be available here. And I'm guessing Jared will get it out to you too. Teva is hiring, by the way. We're looking for 2 data scientists who are familiar with the open source tools, R, Python, 3 to 5 years of experience. Some very cool work, part data science, part consulting. If you have fintech experience, that'd be a big, big plus. If that's of interest, just see me after here, please. Cool. So, Datatable. Quick show of hands. How many of you touch Datatable on a regular basis? Daily, weekly? Okay, almost half. Cool. So, Datatable first came out in 2006. It was brought out by a gentleman by the name of Matt Dole. And he was looking to create a super fast package that addressed some of the shortcomings he perceived with the standard DataFrame. And as of today, it's got a ton of traction, and it's one of the most followed tags and packages on Stack Overflow. Why should we consider learning or embracing Datatable? There's really, in my mind, 3 compelling reasons. One is it's crazy fast. I mean, really, really fast. I work with 10 years of bank data to do all sorts of compliance, Basel, CCAR modeling. I could take 10 years of account history and pivot it sort of kind of the way you would a very small Excel spreadsheet. And for me, the big benefit of that, one metric says if you as a data scientist are spending half of your time looking for new patterns, looking for new insights, and half of your time managing data, that's a pretty good balance. From what I've seen, more than not, spend more time in the data management bucket. And for me, Datatable has dramatically enabled me to focus on finding new insights, trying new methods, because the speed of data management is just not a constraint to me. Second reason is it's concise. There's 2 sides of concise. There's before the learning curve and after the learning curve, and each tells a very different story. Hopefully in today's presentation, will help you come through and compress that learning curve for Datatable. We'll talk about both sides, but we'll spend a good amount of time talking about what Matt Dole designed and why, to me, it's a compelling design. And lastly, Datatable integrates really, really well with R and all the rich functions and packages you can tap into. So these are the 3 big themes that we're going to touch on tonight. Fast is a relative thing. As data scientists, hopefully we aspire to quantify things, but that skateboard's looking pretty good to that turtle. Objectively, Datatable's fast. Some of you may have seen this. These are benchmarks put out by the Datatable team. They've been refreshed recently, within the last couple of months. What we're seeing here are 5 different tests, top to bottom. The top is geared towards, it starts with 1 billion rows, 9 columns, 50 gigs of data. That's pretty big. The top has fewer groups, each group with more data. The bottom has more groups, smaller data. And the one I'd like you to take away is Datatable at the top in blue is shorter, is smaller than the rest. And shorter on these graphs, on these bar charts is good. So it is substantially faster than dplyr. And it's pretty competitive. Spark is a pretty damn good platform. And Datatable is very, very competitive with Spark. And these are all publicly available. Then what the Datatable team did was they took those benchmark numbers and extrapolated them onto the economics of hosting. So what they're saying is it's really cheaper from a hosting hardware perspective to use Datatable. Why is Datatable different? One of the big reasons is Datatable leverages in-memory data processing. The cost of hardware has come down dramatically. And what Datatable does is it takes advantage of all the memory that's available to it. And that's a big paradigm shift. Memory is fast, it's less taxing on your computer. It really is a huge driver of performance. Who here is familiar with the concept by reference versus by value? Yeah, many of you. Essentially, what the benefit of by reference is that Datatable can manipulate, read, and update data in place. Whereas DataFrame needs to make a copy of that data, do what it's doing, and then make another copy to put it back. Great efficiencies. At times, with fread, fwrite, Datatable will use some parallel processing methods and techniques. Algorithms apparently have some very, very efficient internal structures that Datatable uses and leverages. There's really efficient sorting. We'll go through that in the presentation. And a lot of those methods that Matt Dole and team have used are now finding their way back into base R. And also along those lines, set key is a very efficient way to structure your data. Sort it first and then point algorithms at your data that are highly efficient because they know the data is sorted. We'll see that too as we go through this. All right, let's shift gears to concise. One of my favorite comic strips, Calvin and Hobbes. So this is Calvin's view of concise. His book report is crazy concise, and he's a concise writer. All right, let's quantify a bit what concise means here. Suppose our task is to look at empty cars and do a little bit of filtering and some aggregations, okay? The data set, as we find it in R, has 32 rows, but we're going to aggregate this by cylinder and doing a bit of filtering. Here's a bit of SQL code it would take to create that aggregation. What we're saying here is that a large quantity of the SQL code is repetitive. And the way I'd like you to think about this is repetitive not from an individual transaction, but if we're building a capability, something that solves a business problem, for pricing, for market optimization, we're going to have lots of this code that we have to create, debug, navigate through, and if we inherit something, get our heads wrapped around. So here what we're looking at is 65 characters, roughly half of that is repetitive. Similar code for DataFrame has about 90 characters, of which 40 are repetitive. And we can see here that the DataFrame code is function-centric. You start with your function, and you pass in each parameter. And that's important because each parameter doesn't necessarily know what the other parameter contains. Why is that important? Because you have to explicitly enumerate to each parameter what your population is that you're passing in. Datatable, on the other hand, is data-centric. So we start with the data and everything flows from there. And it has 3 really concise parameters that we're going to talk about in depth and breadth here. 27 characters, 4 are repetitive. It's data-centric. So in total, if we look at the broader set of SQL and data table functions, 6 repetitive characters for data table, 34 for SQL, and that's a count of repetitive characters. There's 2 contexts I'd like you to think this about. These are both real-world contexts. I used to be on top of a pricing analytics group for a big bank for their auto financing group. And I inherited a pricing engine. It was crazy complicated. There's probably 10 models that went into pricing. This is the system that when you submit the application to an auto dealer, returns a price, 6%, 8%, 4%, whatever. It had to pull from 6 different platforms, and it was all written in SQL. When I printed out the code, it was probably somewhere on the order of 80 pages of code. It was massive. It took me months to get my head wrapped around that. So if we think of this on a 6 to 1, let's cut it in half, let's say 3 to 1, it would take, let's say 100 pages of code and bring that down to 30. Same function, same functionality. So to me, there's a ton of value in that concise code. I think it's quicker to develop, it's quicker to debug, and you're much, much more agile in maintaining it over time. All right, that's the other side of concise. Does anyone know what movie this is from? Shining, that's right. That's right. Okay. But I do want to be cognizant of the other side of concise. Concise is great and can deliver great code, but if you're just starting that learning curve, concise and lots of shortcut symbols can increase your learning curve. So I do want to acknowledge that, and a big part of what I was thinking about while pulling this together is how to shorten that learning curve. All right, shifting gears to integrated. Any R function from any R package can be used in data table queries. I mean, that's amazing. There's so many rich packages and functions already written and available to us. And we're going to see that a lot as we go through some of the code samples. Okay. Let's shift gears over to syntax. And to me, this was one of the harder things as I came through the learning curve. Honestly, I'm not a trained statistician. I learned this on the job. So what is I, what is J, what is by, and C? There's a way to think about that. I think that might make it easier for you to get your head wrapped around. Each of those functions and concepts available to us in Datatable are available to us in SQL. First, we're starting out with our Datatable name. That's analogous to our for clause in select. The I, first parameter, is all about filtering, equivalent to our where clause. J, there's a lot to J. For now, I'm going to simplify it. J is really our select list. That's where we're enumerating variables that we want to do something with. The third parameter is the by clause, which is equivalent to SQL's group by. And this last parameter, C, I'm calling C for chaining, enables us to take some of the core capabilities of Datatable and chain them together. And that is where we can get our order bys and our having clauses and things like that. Is this helpful? All right, let's get into some code. Let's connect to the Datatable library and expose it to R. And what we're going to do is we're going to take empty cars and we're going to convert it into a data table and call it dt.emptycars. Data table, by the way, unlike DataFrame, they're very similar, and DataFrame is a type, a data table is a type of DataFrame, but it doesn't have row names. So we'll use the parameter keep row names, set that to true, and that will take the DataFrame row names and create a column out of it. All right, filtering. As I said, empty cars has 32 rows. Let's display only those cars that have 8 cylinders. So we'll use the first parameter, the I, filter out where cylinders is equal to 8. Next, let's layer some more conditions on top of that. So it was 14 or so rows. Let's bring that down to 2. And we'll do that by adding on 2 more conditions. Let's say where the weight is less than 4. I'm guessing that's thousands of pounds. And I would like you to pay attention to the third filter, which is a like clause. And we're saying there that the row name is like or contains abbreviation for Mercedes. That's really powerful. It's really powerful because we're essentially, the way I think of it, is we're creating an R vector. And we're passing that R vector into our I or filter clause of data table. And that opens up a ton of possibilities to create some really tight, slick code, which we'll see as we go on. More filtering. If we want to see the first 5 rows, we can just index that 1 to 5, which eliminates the need to take something out of a data frame, top it into an intermediary table, and head it. Cool. Now let's get some data out. Let's say we want to get the row names or cars. We can move from the I parameter over to the J parameter, take row names out, and take it out as a vector. Alternatively, data table can use this double square bracket syntax, get the same result, but apparently this is much, much more optimized. Also a vector output. And let's start getting data tables out. So here, we're going to move away from an individually enumerated column and start using our lists. Very similar, but what we'll get here on the output is a data table. We can start extending this to add any number of columns we'd like and grow our output data table. Now, data table, like any package, has many different syntax which will give you the same output. And here, we're going to start getting into some of the shortcuts that were built into data table, and hopefully, this will demystify a bit of what data table does in its syntax. Okay. 4 selects, same result. The first is what we saw on the previous slide, from empty cars, taking 3 columns out. The second is exactly the same with one difference. There's a shortcut inside of data table. We can abbreviate list and replace it with a dot. Same exact result. Now, if for whatever reason we don't want to use a list, let's say we have a vector, we're passing it into a function, we can use that. We can use a vector and specify the vector in the second parameter, the j, and in the last third parameter use with equals false. Very, very useful if you're generalizing functions with data tables. Last, also vector-based, but instead of explicitly enumerating a column, we're going to use the column numbers. Good? All right, continuing with the select clause. All right. Data table has a very cool feature that will let you specify which columns you choose to manipulate. And that feature is accessed through this abbreviation .sd. So SD is a token, and it's telling Datatable that somewhere in this syntax there are variables explicitly enumerated that you should process on. So in this particular case, it's going to say in the SD columns, start with row name, go through to cylinder. And you can see that on the output down there. Okay. Suppose you want to make some code generic and run it on many columns, and you want to specify what that column is in your code to execute. You can use this double dot notation. And what the double dot notation is telling Datatable is the column you're seeking to process is a variable name. Look in the contents of that variable name and execute your code. Again, very, very powerful when you want to make general purpose functions. All right, let's shift gears over to group bys. Again, 32 rows in empty cars, but we want to group it and aggregate it up to, in this case, cylinder, and we want to apply the mean function for miles per gallon. So we're going to use the third parameter, the by, to specify the cylinder and add the mean function to the j parameter in the middle. And by the way, there's a cool thing that I haven't shown here, which is that by clause, you can use vectors. So if you want to aggregate by multiple variables, you can just drop that in here too. Here what we're doing is in the aggregate function, we're defining what we want the name of the output column to be. So here it was V1. Here on the output, the column name is MPG. Okay. There's something different about this function, and I'm going to ask you what it is once I'm done explaining it. What I'm trying to do here is to apply more and more of R's functions that are accessible to us inside of Datatable. So here what we want to do, let's say we have a new data set. We want to start seeing on a broad basis what the contents of that are. And what Datatable does really well is it lets us crunch big data in a short amount of time. So here, what we're saying is let's aggregate our data, here by cylinder. Let's get the mean, but we want to apply that mean not to one column, but to many columns. And we do that by using the combination of the SD columns. So that's saying start on the left at miles per gallon and end at carburetor, and everyone in between. And use the lapply, the SD, and the mean to apply that broadly. Okay, so that's what this code is doing. What's different about this code? Pardon? Yes, exactly, exactly. This piece of Datatable code has 4 parameters. Everything that we've talked about up to this point had 3. So most of the time you're only going to have 3, generally speaking. But here with the SD and the SD columns, we have an extra parameter. Chaining. The concept of chaining in the Datatable world is to take basic blocks of Datatable functions, like that, and keep appending them onto the end, not to hit people with pillows. Okay. So what we're going to do here is we'll use the same example that we had before. We'll aggregate by cylinder. We'll apply the mean to miles per gallon. But then we'll take that result and we'll say filter it where the aggregate miles per gallon is above 16. So whereas before this returned 3 rows, now it's returning 2. And it's great, because if you're working with really large data, there's no need to have an intermediate data frame, data table. It's all handled for you internally to Datatable. Same exact concept with chaining and order by. We'll take the aggregate results and we'll sort them ascending with the minus sign by miles per gallon, which has an inverse correlation with cylinders. Vectors. By the way, do you guys know what movie this is from? Airplane, okay. Do you know the name of the character names in the scene? Pardon? Over. Vector. Victor's one. Pardon? Yes, no, Clarence. What's your clearance? Clarence. And Roger. Roger. Okay. All right. Why vectors? So first, I just want to touch a little bit on some of the percent in manipulation with vectors, and I want to go into some of the power of Datatable with vectors. Basic examples, vectors of 1 to 2, 1 to 6. The third line of code, 1 to 2, percent in, percent 1 to 6. What's that going to return? A vector of length 2 of true, true, because the 1 and 2 both exist in the 1 to 6 vector. And if we flip it around in the fourth line, 1 to 6, percent in, percent 1 to 2, will be a return of vector of length 6, true, true, 4 falses. Because the 1 and the 2 are there, but the 3 to 6 are not. You can see that on the bottom. Taking that to the next step, the vector for cylinders. So we're saying for the vector of 32 cylinders, where are they in the other vector of 4 to 6? And we get on the bottom that true, the vector of 32 true falses. That concept is really powerful because at a very large scale, you can do this type of processing amongst disparate data tables. I had this one, well, let's go through the code and I'll tell you. So pulling it all together, we're dropping that vector of booleans generated by the percent in into the I parameter of data tables. And what this is going to give us is only the 4s and 6s. Then the next chain is going to say the first 5 rows, and then the order by is going to sort those first 5 rows. I've had examples where clients just dump a crazy number of tables on me, 400 raw tables. Our IT guy is crunched. We don't have any documentation. Good luck. We're all counting on you. And interrogating those tables with this syntax, you can start to demystify the relationships between those tables. You know, if you have one table that's got 6 keys, I can test where those keys exist and don't exist in other tables at a very large scale and very quickly. So this is a recap of the select from, where, group by, and order by, and how they interrelate between Datatable and SQL select. All right, we have 2 more sections I want to go through in syntax, and then we'll dive into some real-world examples. Joins. What I want to do is create a summary table by cylinders, and then join that back into empty cars. So that's what this Datatable syntax up here does. The third by clause is by cylinder. The J clause in the middle, it's a list that has 4 different functions that are doing means and standard deviations, and produces the table on the bottom. Now, we want to join that newly created table back into empty cars. first thing we're going to do is use this set key v function. That all that's going to do is it's going to order our table by the vector we pass in as the second parameter. Then the third line is going to do the join. I'll talk a little bit more about this, but to me, this is one of the less intuitive parts of the syntax. And I'll explain why in a minute. But the end result is the empty card tables on the left and the newly created variables on the right. I generally don't use this syntax. It's more efficient, but I tend to gravitate towards the merge syntax on the right for two reasons. One, processing speed's not a bottleneck. I don't need that efficiency. I'm not doing joins as frequently. And two, there's implied logic between the inner left and right joins in the data table syntax in the middle. The permutation of the x and y will tell you if you're doing a left and a right. The keys that are being joined by are enumerated elsewhere in the set key. It works, it's super fast, and if you need that performance, that's awesome. I tend to gravitate towards the merge syntax, which will do exactly the same thing, and which will explicitly enumerate everything you need to know about your join. It's trade-offs, not right or wrong. And this is all courtesy RStudio, this page, inspired by. So, to sum up some of the key shortcuts you'll find in Datatable. A single dot tells us that it's a list. A double dot tells us the variable, the select entity is a variable. X and Y is a right outer join. And as of putting this together, it kind of struck me that it's really Datatable is kind of ahead of the curve on emojis. So big grin, clown, and what we're leading into here is updates. And the Datatable syntax for updates is colon, full colon equal. And there's a reason for that. In the SQL world, the syntax between select and update are very, very similar. The from and the where can stay the same. Swap out for select and drop in an update and set. Same syntax. There's an elegance to that. So the idea behind the data table design, well, we have an equal in our J clause. We use it for column names. We use it for aggregations. OK, let's add on a colon, make it an update, and the rest of the pieces, the I and the by, stay the same. That kind of makes sense to me, I think. All right, let's say we want to add a new column, and we want the value to be 1 for every row, which I find useful if I want to do a count. I'll just sum up on this column. There's other ways to do it, but this works for me. Layering on a little more functionality. Suppose we want a new column to be the manufacturer name, which is the first word in the row name column. So we'll use gsub. We'll pick off the first word. We will assign that to the vector v.manufacturer, and then we'll take that vector and using the colon equal syntax, create the new column manufacturer. And I broke it apart just so it would be hopefully a little easier to get your head wrapped around. In real life, I would code that all into one statement. And continuing on with the update, suppose we wanted to create a new indicator variable as a potential independent variable. In this case, what we'll do is we'll have an is_Mercedes indicator, and we'll set it equal to 1 under the condition in our I clause that the manufacturer is equal to Merck. There's two things I'd like you to take away from this on the output. Number one, there's no assignment statement. In a DataFrame world, we would have to create this new column and assign it back into a new DataFrame. Very efficient. It's the by reference processing versus the by value processing. 2, on the bottom, there are 7 rows where this indicator will have a value of 1. What happens to the other 25? You get your NA automatically. You don't have to touch it. It's handled for you by Datatable. And you may choose to make that a 0. You may choose to process it as is. It's concise and it's efficient. All right, we're almost done with syntax, and we'll get into some real world stuff. Here, I just wanted to make you aware of other functions available to you from Datatable. There's fread, there's fwrite for getting common delimited data in and out very quickly. It has all sorts of parallel processing features built in. Read and save RDS for writing data tables in and out. Set names, set column order, decast, demelt. You can change your column name, set the order, and you can melt and decast your table using Datatable. It is very fast and it's very efficient. That's all I'll touch on for now. Okay, covered that. All right, getting there. Let's talk about some real world stuff with Datatable. These are features that have been layered on top of Datatable. These are real world examples. And these go directly back to being handed 450 raw ERP tables by the client, CSV, no documentation, no tech guy to talk about. Decrypt these, demystify them, and good luck, we're all counting on you. So, you know, I'm going to jump around here. So the first thing I did when I got this, and I was brand new to R, by the way, when I did this, I created this function called EDD. Think of EDD, Enhanced Data Dictionary, as a variant of the summary function. But to me, it presents the output and describes the variable row by row in a very concise manner. So if you look at the bottom, let's see, yeah, does this work? Yeah. Here along the bottom, I don't know if you can read this so well, but each row represents one variable. It will tell me its best guess at data type. How many are unique? How many are NA? How many are blank and fill rates? For continuous variables, it'll give me the center or the mean and the percentile spread. For the categorical variables or the factors, it'll give me the top 10 values by frequency. Kind of wrap it around a function that'll display it in a shiny package, which is kind of cool. What I did was I ran this 450 times, once for each table. And I stacked all the output together into one data table. And in that data table, I can start making connections between where are the column names similar? Where do they link? Are the number of unique values the same? I can pass this into a generic function to plot these out. And at a glance, I can skim through these very, very quickly. It really, really helped me demystify a lot of data quickly. Time series data. I wind up doing a lot of time series data in my analysis. And here, what I'd like to point out is for a pretty large time series data set, there's over 100 million rows. I'm able to filter and do whatever functions I'd like. So in this case, I'm doing the percentiles. So I've got that set from 0 to 1 in increments of 0.1. And doing the quantile on a lot of different variables at levels of aggregation that I want. So in this case, I'm aggregating by 2 variables in a vector and putting them in here. One of the common problems I find in either debugging something as I'm getting to a master data set, or more importantly, reflecting accurate results back to clients is what? For me, it's getting filters right. It's going to bias your population one way or the other. It's going to account for business dynamics. And to get clients to embrace that, I need to be transparent about what those filters are. And what I find with this code here, in this example, there's one filter, but I have code that has dozens of filters per table. It's all laid out cleanly and crisply. And whoever's going and combing through that code has a quick path to knowing what those filters are. Yeah, there's some scoring code that I sanitize the variable names for. But what I wanted to articulate here is once you have your model trained and you're running it in a production basis, you can produce some code that I think is pretty tight. What's your dependent variable, coefficients, intercept, variables, and in this example, taking that and wrapping it up into a logic model. So my output is always going to be between 0 and 1. This is another function I wrote as I was navigating those 450 tables. I needed to know the Venn diagram view of two different variables. Where do they intersect? Where do they appear in only one side or only the other? So the first two parameters of this function are passing in vectors from data tables. The second two parameters are labels, and then the output is telling me what the union, intersection, and left and right sides of that Venn diagram are. So here's an example of burying inside of your data table a plot call. Really what I want to do is I'm starting to visualize the data, is I want Datatable to crunch the data, and I want to hand off a summary set of data to whatever graphing function is being used. So with this method, we can build the plot directly into our data table. This would produce however many manufacturers there are. I think it was 20. So we'd get one graph for each of these. Another way to think of that, and I got this on Stack Overflow, but I have something similar. This is a generic function. It's going to take as parameters a data table, the variable we want to be the x-axis, the variables we want for the y-axis, and some metrics. I'm sorry, the z is what we want to facet by. It's generic, it's awesome. So what I do here is I go back to my EDD, I know where my factor variables are, I know what my continuous variables are, and then I feed that into this. So I very quickly get through the visualization of a really large group of data. What I'd love to do is to get this plugged into Trelliscope, but I haven't had time to get that to work yet. Okay, let's shift gears. We're going to wind down the code portion of this and talk about something that might be a little unexpected, it might be a little counterintuitive, and it's something that gets me very, very excited. All right, I'm in touch with my inner geek here. It's a server. It's a server I built. When I look at this picture, this is what I think about. It's crazy fast. It is. So what you want to know is it's got 4 CPUs, a lot of disk. Any 2 disks can fail. I could pull them out and the machine will still run. But most importantly, it's got a terabyte of RAM. So I'm surprised that lights don't dim as this thing boots up. this is my team's day-to-day tool for getting our job done. And I cannot underestimate how crazy fast it is. And because it runs out of memory, the physical mechanical side of the server, the disks, which fail most often, they're not used much. I'll read in a big data set, I'll flush it out at the end of the day, so there's a copy on disk. It's crazy fast. Your phone, typical phone has inside of it 8 cores in its CPU. This one has 6,000. It's got it in the form of a couple of GPUs. Here's what I think is the most surprising thing about this. It's got an out-of-pocket cost of $21,000. It's really high-quality hardware, and it's really not that expensive. Now, you have to want to tinker. You have to enjoy that. It's not a perfect solution. We were busy building Basel models. The regulators were coming in at the client site in the next day and a half, and it started throwing out some errors. And apparently there's a history of Samsung solid-state disks melting down. So, but I think we have the right model wrapped around it because all of the code sweeps out to the cloud. All of the original data sets that we work with that were provisioned to us are on the cloud. And if I need to rebuild my master data set at this large scale, I can do it in hours. You know, one of the platforms I've built out was for a big bank. It had trillions of transactions, hundreds of terabytes of data, and it is in use by 2,000 modelers. I would use this in a heartbeat over that. This is such an awesome environment to work with, and it's the memory, it's R, and it's data table. That's the essence of this. Most don't. That is absolutely right. I put that here for a reason, and I'll come. That's a good point. I will come to that. Thank you. That is the perfect lead into this. So one of the things I worked on was transition migration matrices. Some legacy code, when they were first written, however many years ago, they would run in 2 to 3 hours. And really what you want to know is there's a lot of matrix math in this, a lot. Over time, the portfolio of loans grew. More functions were thrown into the code, and eventually it took a day and a half or so to run. So we were asked to take a look at it and to see what we could do. First thing we did was we rewrote the code in R and Datatable, and we got some crazy good performance numbers. In the 1 million row range, what was running in 2.5 days is running in 6 seconds. But we had this idea that instead of looking at this as a report that you run daily or weekly or monthly and look at, what if it was really a simulation tool? And you can do all sorts of what-if analysis on it. So what we wanted to test, our hypothesis was to do this on a GPU. This is 4 years ago. And at that time, the only way we can get into the low-level libraries to manipulate the GPU was through C or Python. All right, so fine. So we rewrote the code into Python. The performance numbers were quite good, but not nearly as good. And my hypothesis, I don't know for certain, but my hypothesis is that was due to Datatable. Same hardware, but the R was really much faster. But then we loaded the data set onto the GPU, and we manipulated it only on the GPU. And we brought that down significantly from 6 seconds to sub-second. And it scales up very nicely in some sort of kind of linear way. That's one thing. The other thing, and this has nothing to do with Datatable. Sorry, it's just kind of fun. It's just a computer vision algorithm. It runs on a tablet I have, and it's 95% it identifies retail products. It's really using pixel data. Right now it's trained for baby products, and it's 95% accurate. That's just something else I'm tinkering with. That's it.
Questions?
One of the challenges is learning the syntax, right, for Datatable.
Pardon?
One of the challenges is learning the cryptic syntax for Datatable, right? I think hacking is.
I'm sorry, which syntax? Okay, yes,
Syntax
yeah,
for
yes.
Datatable. So I think now there's a dplyr library. Do you have any? I'm not sure if you looked at it and any comments on how good or bad it is versus using the raw. I know you cannot do everything, but it's like dplyr, you can it has select, filter, and all that stuff.
Interesting. Is it using the R libraries with dplyr syntax? Is that the concept?
Yeah, you can operate on data tables with that.
That's a very cool concept.
I think it's been around for a few years, from what I know.
I'm not honestly, my first exposure to dplyr, to be honest, was at JD's talk a few months ago. This works really, really well for me, and I don't have a good answer for you.
Last I saw, it works. It was designed Datatable from the beginning. It worked on DataFrame, specifically dplyr, and it's not nearly as performant. Last I saw as Datatable itself, but you're going to use dplyr syntax and beat you around the middle. Which,
Yeah. It's the syntax coming through the learning curve is real, but it's fast. It's super fast.
Simple question on the box that you built. If you built it again, would you do it on the cloud? What would that cost? What would it cost you to build that box again?
I haven't priced it. My hunch is it'll be within the same ballpark, plus or minus a couple $1,000s, and you'll probably get a much, much faster GPU. We do use cloud. We use cloud at a dramatically smaller scale because we're putting two things out there. We're putting all of our code and analysis, and we're putting the data that's provisioned to us, and that's our, in case something happens, we can scale up the cloud and run with it. I started looking at it. I don't know that the numbers I put together are right on spot because I'm, to be honest, not super fluent in the cloud, but the numbers I saw in the spot market had it at something like $40,000 a year. So to answer your question, would I do this again? For me, in a heartbeat, because it's that crazy fast, and I have the comfort that the cloud's there if I need it.
In one of your earliest slides, in the benchmarking slide, you show a Python version of the Datatable. Have you had much experience with that?
When I was doing that, it was not available to us, and that just came out in the R benchmarks that were, these new set of benchmarks came out 2 months ago. But I'm very keen on looking at that. There's some nice features that can make that work. But if you look at the benchmarks, there are certain benchmarks that didn't run on that Python R because it's not yet implemented there. So my view on it is it's a good first step and it's not fully baked yet. This is all the machine I made. There's no, this is all three of these are in the machine I made. No typos. The first column first two columns are without the GPU, so 32 cores only. R's performance with Datatable, Python's performance. This column here, we took the data set and we moved it onto the GPU. The GPU has 6,000 cores. It has, I believe, 8 gigs of memory. And the data and the processing in this scenario occur completely within the scope of the GPU. And the GPU is awesome at anything connected with dot products or sorting, because those are two problems that lend themselves very, very nicely to parallelization. And that's what's inside of much of the deep learning and the computer vision stuff you see out there. They're based on GPUs and products like GPUs.
A simple question on syntax. Any solutions for embedding functions within select segments or have you with data table, like equivalent to the per function, per package?
I am not very familiar with the per package.
Do you ever nest custom functions, like embed them, I should say, within like select segment equivalent?
Yes, I do. And the way to do that is to, within the J clause, is to put your code within squiggly brackets. And you can embed R code within that J function using that method. A lot of the, I don't know if you're familiar with Shiny. No, but basically the idea is you start and end with the squiggly brackets and you drop in R code with that. So my hunch is that would work, but I can't say that I've done it with the per package. I've done it with other functions.
I use Datatable at work, and one of the things I find with Datatable alone, do you think there's going to be an Datatable needs an ecosystem surrounding it, perhaps the way that dplyr has, for it to be some higher adoption rate by data scientists, or is its primary strength that the ecosystem is R or based on itself?
So the question is, do I think there will be an ecosystem around Datatable similar to the ecosystem around dplyr? The design decision that went into Datatable is to expose R functions within Datatable. So I think implicitly that ecosystem exists. I mean, I'm writing a matching engine now. And it's awesome to be able to use a lot of the string distance libraries that are accessible to me and invoke that from within Datatable. I guess you could look at that through the lens of an ecosystem, but it would be the broader R ecosystem. It's probably an ecosystem that's not marketed as an ecosystem.
Anyone else? Last chance.
This is really silly, but when you rewrote your code for R and what using pandas
It was pandas. It was exactly pandas. It was there was some NumPy in there too for some of the dot product. You can distill this code down into some algebra and dot products. That's the essence of it. And NumPy is very good at those dot products.
All right, second last chance. Okay, thank you very much.
Thank you. Thank you.